5, 6 is just more on solving solving equations of so more complex equations of exponentials and logarithms, and then some basic applications. All right, the applications really won't be too bad; they're real basic ones. But we are going to get into more complex equations and complex logarithms. But the process is the same as what we did in the simple cases. We just have to do a little more algebra to get there. So the first step is always use our law of logarithms, law of exponentials to simplify, to compress the logarithm or the exponential into a single log term and a single exponential term. So we want to is get on both sides a single term. Alright, set equal to a single term. If all you have is one logarithm on one side or one exponential term on one side, then you use your inverse property and your law of logarithms, law of exponentials to solve, like we did the simple cases. If you have a log term on both sides, it should be the same base. It should be base 10, base 2, base whatever. And then we know, using the uniqueness property, that whatever's inside the logs have to be equal. So you kind of take what's inside, set them equal to each other. Same thing for exponentials. If you got the same base on both sides, what's in the exponent has to be equal. And so again, that's the uniqueness property in both directions. If you can't solve algebraically, there is always graphical. You could solve all. The downside to graphical is you can never find the exact answer, but you can always find an approximate answer. And actually, we're going to look at some examples later on in this set of notes where you have to solve it graphically. There is no algebraic way. The last thing you kind of is sort of a catch with logarithms. If you're solving a log equation, you must check your solution. Remember, logs are only true for positive values. No zeros and no negative values. So if our answer comes out and it gives us a negative value or a zero value in my logarithm, we throw it out. Right? And we throw those out and they aren't included. And so we can get no solution for those. Now exponentials, you don't have to worry about it. We can plug anything we want into an exponential. So just the logs. You have to check the logs equations. You do not have to check the exponential equations. Alright, so we're going to start out with the exponentials because they're the easier one, and then we'll do the logs. So we're going to start out solving exponentials first. Alright, so I'm going to do the first couple of examples, and again, I'm going to keep my videos fairly short. So I'm going to do the first 2 examples, and then I'll stop and do the next video and do the next couple of examples. Alright, so both of these, so these are exponentials. Find the exact form by hand, and then find the approximate form rounding 3 decimal places. Alright, so first step is isolate, so A, I'm going to do A first. Isolate the the exponential term, 10 raised to the x plus 2. Alright, so I need to move my 2 to the other side, so I get to 10x plus 2 equals 6. Get rid of that 2 out front by dividing, and so now I've got 10x plus 2 equals 3. Alright, now there's 2 ways you can solve it. You can rewrite it as the log, or you can use the uniqueness property. I like the uniqueness property. I mean, I'm going to take the log base 10 of both sides. Alright, whatever I do to one side, I have to do the other. The reason why I do that, this log base 10 cancels with that 10. They undo each other. Leave me with just the exponent, which was x plus 2. Over here, I still have a log of 3. And it's log base 10, right? If I write it without anything, it's base 10. And then it's just solve for x, I subtract the 2. And so x is exactly log base 10 of 3 minus 2. Log base 10 of 3 is a number. It's an ugly number, but it's a number. And so that's the exact answer. And then you type that into the calculator, because I could type log base 10 in, and find the approximate answer rounding 3 decimal places. That comes out negative 1.523. Right, and there's the first example. Alright, so now I'm going to go back up here. And I don't have to check these as they're exponential, so that's good. There's my answers. Alright, now part B. Alright, so this is the base E, so it's going to be my natural log I'm going to use, right? Base E is the natural log. So first thing, though, I have to isolate there's a 3 out front. So this was a little simpler. All I have to do is get rid of the 3 by dividing both sides by 3. So I've got E to the negative 0.02x equals 9. Again, I get rid of the e by taking the natural log, the ln, of both sides, right? Whatever I do to one side of my equation, I have to do the other. The natural log is the log base e, so these two things undo one another, leave me with that negative 0.02x on that side. Still equals the natural log of 9 on the other side. And then then to solve for x, I get rid of that number out front by dividing it out. And so x is exactly the natural log of 9 divided by the negative 0.02. And then to find the approximate answer, you take your natural log is on your calculator, right? You have an ln key on your calculator. So you take the natural log of 9 and then divide it by, don't forget the negative 0.02, and round 3 decimal places comes out negative 109.86. Let me double check that. So, yeah, negative 109.861. You can read that. Alright, so there's the exact answer and there's the approximate answer. Alright, so I'm going to stop there, and I'm going to pick it up in the next time to keep these videos fairly short, so I'm going to pick up the next examples in the next video.